In this lesson we're going to look at gamma emission. Now gamma emission is different from alpha or beta emission because it does not involve the emission of a particle. So what is gamma emission? Well, gamma emission is really the emission of a high energy packet of electromagnetic radiation. Okay, so you can think of it like X-rays but with much more energy. So an example of a radioactive isotope which results in gamma emission, we're going to take something called technetium-99m. I'll explain what that M is in a minute. Okay, and when that decays, it results in the emission of a gamma ray. Okay, there's our high energy packet of electromagnetic radiation. It's a gamma ray. Okay, so we can write here the nuclear formula for technetium-99m, and technetium has an atomic number of 43. So what does this 99m refer to here? Well, this refers to what we call an isomer of technetium. That's to say, isomers are nucleuses that have exactly the same number of neutrons and the same number of protons. So in that sense they are identical, but they have different energy states due to different configurations or arrangements of the protons and neutrons in that nucleus. Okay, so we can talk about isomers of radioactive isotopes which have the same number of neutrons and protons but with different energy levels. Okay, so this M stands for metastable state. That's a big word which means that it has a higher energy level. All right, and we can represent that with an energy level diagram. Okay, so this is our energy state for technetium-99m, and you can see that when that decays, it emits a gamma ray and drops down to a lower energy state of technetium-99. Okay, so as it changes state from this higher metastable state to the lower state of technetium, we get the emission of the gamma ray, and the energy of that gamma ray corresponds to the difference in energy between these two levels, between the metastable state and the normal state of technetium. Okay, so we can complete this diagram above. So we've got technetium-99m is changing into technetium-99, okay, the normal state of technetium, and we get the emission of this gamma ray. So whenever you get only gamma ray emissions, then actually nothing changes in the nuclear configuration. The atomic number stays the same and the mass number stays the same. These do not change. Now there are other elements which will decay into both alpha and gamma emission, and an example of this is uranium-238. Okay, that decays into thorium-234 and the emission of an alpha particle. As we say, this means that the mass number is reducing by 4, 238 to 234, and the atomic number is reducing by 2, 92 to 90, so uranium becomes thorium. But also in this particular nuclear decay process we get the emission of a gamma ray. So gamma rays can be emitted either on their own when one nuclear isomer changes into another, as we've just seen, or they can be emitted with an alpha particle when an alpha decay process takes place in a nucleus.